You've probably been in one of those meetings, right? Where someone confidently says a network is properly segmented, and everyone in the room just kind of nods along. But what are they actually talking about?
Well, it might sound super complex, but it's really not. Figuring out what makes a network truly secure boils down to just 4 basic building blocks. Once you get these, you can look at pretty much any network diagram and see exactly where the real security is and, more importantly, where it isn't.
So here they are: ports, firewalls, subnets, and VLANs. These are the tools every defender uses to build a secure perimeter. Let's start with the first two, which I like to think of as the doors and the filters of our digital world.
First up, ports. Every single device on a network, your laptop, servers, everything, has literally thousands of them. But what exactly are they?
Okay, so a port isn't a physical thing you can plug a cable into. It's a software idea. Think of it as a specific numbered location where a program is just sitting and waiting, listening for a connection.
The absolute easiest way to think about a port is as a numbered door leading into a computer. And here's the crucial part. By convention, certain numbers are used for specific services. This whole system of conventions is basically what makes the internet work. For example, port 443 is almost always used for encrypted web traffic, HTTPS. Port 22 is for managing Linux machines. This setup is incredibly helpful, but it also creates what we call an attack surface. Every single one of these open ports is a door that an attacker can try to jiggle open.
So, if you're in a governance or risk role, this translates into some really simple but powerful questions. Do we even know which doors are supposed to be open? Are the really sensitive ones, like the admin ports, facing the public internet? And when was the last time we actually checked to see which doors are open versus which ones we think are open?
All right, so if ports are the doors, then firewalls are the security guards standing right in front of them. At its heart, a firewall is just a filter. It sits there, looks at every little piece of data trying to get from one place to another, and makes a simple choice: allow it through or deny it.
A firewall just follows a list of rules. It might have a rule that says, allow traffic to the web server on port 443. But the most critical rule, in any good setup, is always the very last one: deny everything else. This is the default deny principle, and it's huge. It means that if we haven't specifically said something is allowed, it gets blocked. No exceptions.
This leads to some really sharp questions you can ask. Is our firewall actually set up with default deny? Are the rules written down somewhere so we know why we opened a particular door 6 years ago? And are we actively looking for those super dangerous any-to-any rules? Because those basically just leave the front door wide open. Okay, so we've got our doors and we've got our guards. Now let's talk about how we lay out the neighborhood itself, and that's where we get into subnets and VLANs.
A subnet is really just a group of IP addresses that we treat as a single unit. It's our way of slicing up all the available network addresses into logical, manageable chunks.
And this analogy is just perfect for understanding the security side of it. Think of a subnet as a single street. All the houses on that street, they can talk to each other directly, no problem. But if you want to get to a different street, you have to go through a controlled intersection. And that intersection, well, that's exactly where we can place our firewall, our guard, to inspect the traffic. Subnets create boundaries. This helps us ask if we're creating meaningful boundaries in the first place. Are the employee workstations on a different street from the critical servers? Is the guest Wi-Fi on a completely separate street that only leads out to the internet? And here's the kicker. Is there a guard at the intersection between them? Now, back in the day, creating all those separate streets meant running separate physical cables and switches for everything, which got really expensive. That's where VLANs come to the rescue. A VLAN, or virtual LAN, lets you create different logical networks that all run on the exact same physical hardware. The best way to picture this is an open-plan office. Everyone's in the same big room. But there are painted lines on the floor to show where different departments are supposed to sit. People generally agree to respect those lines, but there are no actual walls. A VLAN is just like those painted lines.
So here's the crucial point. A VLAN by itself isn't a security control. It's just organizational tidiness. The real question you have to ask is, what's enforcing the separation between those painted lines? Is it just a simple router that lets everyone cross whenever they want, or is it a firewall that's actually checking IDs? Because relying on VLANs alone for security is like trying to protect a bank vault with a roll of masking tape.
So now that we have all these building blocks, let's see how they come together to create a classic, really effective security design.
Probably the most famous example is something called the DMZ, or Demilitarized Zone.
A DMZ is just a buffer zone. Let's walk through this. We take our public-facing web server and we put it on its own special subnet. That's the DMZ. The first firewall only lets web traffic in from the internet. But to get from that web server to our really important internal database, traffic has to pass through a second firewall. And that firewall only allows one super specific type of connection. So if the web server gets compromised, the attacker is trapped in that little buffer zone, not running wild inside our entire network.
And this brings us to the one single concept that ties all of this together. It's the real why behind every subnet, every firewall rule, and every DMZ.
That concept is blast radius. It's a simple but powerful idea. If one machine gets compromised, how much damage can actually be done? How far can the attacker move from there? In a totally flat network, the blast radius is, well, it's everything. But in a well-segmented one, it's contained.
And this, right here, is the ultimate question you should ask of any network design. Just pick a machine, any machine. Say, your main web server. If that machine gets hacked, right now, what else can the attacker reach from it? The answer to that question tells you more about your actual security than any report ever will. The whole point of good network design is to make that answer as small as humanly possible.
So, the next time you're looking at a network diagram or talking about security, try to cut through all the jargon. Just ask that one simple question. What is the blast radius? Because at the end of the day, that's what this is all about.